So please make a note that we're going to skip over problems 8, 9, and 10 on this sheet because you've already done them. This sheet repeats 8, 9, and 10, which we did in the very first unit. Okay, so we're going to go right to the very last problem to complete this set and to complete this guided practice, which is number 11. We're going to use this diagram here to find the measure of the indicated angles. Okay, so the first thing you're going to notice is we've got to actually find the measure of these angles. We're not given any angle measurements at all, right? So you might first be wondering, how am I going to start doing this? What kind of clue can possibly tell me what an angle measure might be, and I don't have any measure that I'm given to begin with? But the key lies in this right triangle over here, the triangle on the right side. Its three sides are congruent, which means it is an equilateral triangle. And I hope you recall that we once discovered that an equilateral triangle has not only the three of its sides equal, but also all three of its angles are equal as well. And since the angles have to add up to 180, 180 divided by 3 will give us the measure of each angle. And 180 divided by 3 is 60. So we know that each of these angles is 60 degrees because every angle in an equilateral triangle is 60 degrees. And that already gives us the measure of angle 1. So we can write in 60 degrees here. Now what about the measure of angle 2? 2 is vertical to 60 degrees, so it also must be 60 degrees. Well, you might say that was just luck so far, okay? We just happen to be lucky. We just happen to have an equilateral triangle. We figured these are all 60 and this is 60, but now it's going to get tough. How are we going to figure out angles 3, 4, and 5? Well, it's not that tough, okay? It turns out that we don't know about this triangle whether it's equilateral, but we do know that it is isosceles, right? It has two of its sides congruent, which means that the base angles are equal to each other. One of the base angles here is 3. I'll call it x degrees. And the other base angle isn't labeled, but I can also call it x degrees. So I know that these two angles have to be the same measure. And now I've got a triangle, and I can add up its degrees to 180 and solve for x. So let me go ahead and do that. So I've got 60. And this is adding the three angles in the left triangle, plus x equals 180 degrees. And now that's the same thing as 60 plus 2x equals 180. Or if I subtract 60 from both sides, I get 2x equals 120, and then x equals 60 by dividing both sides by 2. I know you know how to get to do these last two steps. So it turns out that this third triangle is also an equilateral triangle. Its two remaining angles are also 60 degrees. So this is 60 degrees, and this is 60 degrees. So now we know these angles, which means that we know angle 3 is 60 degrees. So we can put down 60 degrees for angle 3. And angle 4 is vertical to angle 3, so therefore angle 4 is also 60 degrees. And what about angle 5? Well, angle 5 is a linear pair to this angle here, which is 60 degrees. So that means it's supplementary to 60 degrees. And a supplementary angle to 60 degrees is 120 degrees. So the measure of angle 5 is 120. So starting with only limited amount of information, we were able to use all that information strategically to figure out every angle in each of the triangles and be able to figure out how to calculate the measure of the remaining angles.